Hi, I'm Dr. Chad Larson. Is it good to exercise in a fasted state? That's the question that we're going to try to answer today in this episode. And there's an interesting article that was published just recently, just a few days ago, that'll give us a little bit of information to help us really answer that question. For many years now, I've mostly preferred to exercise in the fasted state, and I've got my reasons why I do that, and I've also recommended that many times to patients as well. But it's good to explore the literature and see what the scientists have to say about that. So we get a little slice of an answer with the study that I'll report on today. Is a study that evaluated a hormone called ghrelin. Ghrelin is spelled G-H-R-E-L-I-N. Ghrelin is a hormone that's produced by the stomach in a fasted state that tells your brain that you're hungry and to eat. But what we found in the study is that actually it has some other purposes as well. And that's mostly what we'll talk about, this kind of new information about why ghrelin is produced and kind of the cascade of effects that it has on the system. So it was interesting. They took, this was an animal study. It was on mice, and they evaluated ghrelin in a couple interesting ways. And just to take kind of one step back, ghrelin is one of these hormones that are part of our appetite regulation. And typically, sometimes we oversimplify it into ghrelin and leptin. Ghrelin gets released when we're hungry, and kind of in what we call a fasted state, and leptin gets released in a fed state. And so leptin gets released and tells the brain to stop eating, and ghrelin gets released in a fasted state to tell the brain that you should eat. It's a little oversimplified. There's lots of other hormones that we have to think about. Things like cholecystokinin is associated with that, peptide YY, some other nutrient sensors like insulin, AMPK, mTOR. It's a pretty complicated dance of all these different hormonal signals. And this is why we've talked about in many episodes before that, fat accumulation and fat burning is really a hormonal concept. It's a hormonal process that happens in the body. Lots of interesting hormonal kind of moving parts. But this hormone called ghrelin is interesting. And what they did is they evaluated mice. And so they had mice that were just kind of normal mice. They had that they just kind of fed what they called ad libitum, which means the food is just always there. The mice can eat whenever they want. And then they had mice that followed a particular time restriction. They call it time restricted feeding. With humans, we call it time restricted eating. Also, sort of intermittent fasting is a similar process where you kind of extend your overnight fast. So instead of fasting for 9 or 10 hours, maybe you're fast for 12 hours or 14 hours or 16 hours. And then you have a restricted eating window to 8 hours or 10 hours or whatever the case may be. And so that's what they did in this study. Is there was a particular time restriction where the mice in that second group were allowed to eat. So ad libitum, or eat as often as they want, in group 1. Group 2 was they had this sort of time restricted eating window. And then they actually had a third group of what they call GKO mice, or ghrelin knockout. And so they're genetically engineered to actually not produce this hormone ghrelin at all, which was an interesting concept and kind of added another layer of understanding to how ghrelin works. So what they figured out is in the fasted state, as we already know, we've known this in biology and physiology for a long time, that in the fasted state, which, just as a quick aside, for humans, we consider the fasted state 10 to 12 hours of no calories. In mice and other animals, this could be a little bit different because their metabolism is different. But for humans, we'll call that about 10 to 12 hours is considered fasted. And you're pretty much either in a fasted state or a fed state all the time. If you haven't eaten any calories for 10 to 12 hours, you consider to be in a fasted state. So they had these groups of mice, and the second one had this time restricted eating window, and as expected, ghrelin went up in that fasted state. So that wasn't real surprising. But what was surprising, they had a really sophisticated way of measuring their voluntary activity, let's call it exercise. And their voluntary activity went up considerably in the fasted state when ghrelin was at its highest. And in the other group that was just kind of eating whenever they wanted to, they did not have this spike of ghrelin, and therefore they didn't have this spike of voluntary exercise. And then in the mice that were genetically engineered to not produce ghrelin, they also didn't get a spike of ghrelin, obviously, and they also didn't get a spike of voluntary exercise. So they thought this was interesting. And then they, because they're mice, they can do certain dissections and they can do certain evaluations that you can't really do in humans, like look at certain parts of the brain and other neurotransmitters. So what they found is that, and this is the first time that I've read about this, where as ghrelin went up, voluntary exercise went up, and then the brain gave them a little bit of a reward. It's this neurotransmitter called dopamine. We've had past episodes where we talked about dopamine, but dopamine is this interesting neurotransmitter. It's kind of part of our reward and motivation sort of neurotransmitter. It gives us a little treat, little brain treat, little motivation, a little reward for exercising. So as the fasted state goes up, ghrelin goes up, and then this dopamine neurotransmitter goes up, and this all translates to more voluntary exercise. So then you think, kind of biologically, why does the body do that? Why in a sort of hunger state, in a fasted state, why does voluntary exercise go up? And it's very simple. It's just food exploratory behavior, basically meaning in that fasted state, you have certain physiological reactions that manifest in the system to reward you or to allow you or to encourage you to go seek more food. So by exercising in the fasted state, it kind of doubles down on this process where ghrelin actually kind of helps to promote this voluntary activity. So what happened with the mice that had no ghrelin? They're genetically engineered to not produce any ghrelin at all. So obviously they did not have the release of ghrelin. They did not have that increase of dopamine and exercise, but then they did something interesting, and they actually injected ghrelin, or technically a ghrelin agonist. So is a substance that binds to the ghrelin receptor, creating a ghrelin response. And guess what? They gave them ghrelin, and their volunteer exercise went up significantly after they had that injection of ghrelin. So it just tells you that ghrelin is a key component of the whole kind of cascade of hormonal kind of reactions that happen in the fed and fasted state. So just to circle back to the original question, is it okay and is it good? Is it okay to exercise in the fasted state? And the answer is yes. Not only is it good, but it really kind of helps you to double down on the process of fat burning, because if you think about it, you're in the fasted state and ghrelin is going to go up. That's just a natural physiological response. And then you're going to exercise, because we know that this causes this kind of voluntary movement, this kind of behavior to seek more food. So your body wants to exercise more. And then you get a nice little treat of dopamine release in the system. So that gives you further motivation to keep exercising. So this is just good confirmation that, maybe not for these reasons, but something that I've done myself for a long period of time, something that I definitely have recommended to patients, and it seems to work out really well, especially for patients who were trying to get a certain degree of fat burning happening, and just kind of help to boost up motivation to exercise. Doing it in this fasted state is a really, really great way to do it. And you go, all right, well, this is on mice, and that's a fair response. That does this really translate to humans? Usually, there's a lot of things that don't translate between kind of interspecies, but hormones have really seemed to work out to translate. At least the effects are pretty similar between different species, and we've seen that with some of those hormonal responses that I mentioned earlier. So ghrelin, when they do end up running similar studies like this in humans, we'll probably see a very, very similar reaction. And based on sort of clinical evidence of the effects of exercising in the fasted state, not only for me personally, but also for patients, they really seem to like it. It's something that's very sustainable and helps keep people on the right track. So I hope that helps. I'll keep reading the studies and bringing you the information. Until then, keep it real.